linear inequalities. Find all the integral values of x which satisfy the inequalities 2 into 2 minus x is greater than 4, is less than 4x minus 9, which is less than 4x plus 11. Now we solve the the first part first, that is 2 into 2 minus x is less than 4x minus 9. We solve that part first and we find the x is 2.5. Now we solve the other part. 4x minus 9 is less than x plus 11, and we find that x is greater than 6 and 2/3. Now we know now x is less than 2.5 and x is now sorry for mix up. We know that x is greater than 2.5 and x is less than 6 and 2/3. So we can write that equation and show that x is greater than 2.5 and x is greater than 6 and 2/3. For these inequalities, know that the pointed pulse points are the lower figure. Now if we write x in the middle and the pointed part is pointing at 6, it means that 6 is greater than x, or x is less than 6. And the other side, the pointed part is pointing at 2.5. It means that x is greater than 2.5, or 2.5 is less than x for that matter. Now, what are the points in between there? The points in between there, you can clearly see we have 4, 5, and 6. The diagram below shows the graph of y is equals to 3x over 10 minus 3 over 2, and 5x plus 6y minus is equals to 30, and x is equals to 2. By shading the unbounded region, determine and label the region R that satisfies the three inequalities: y is greater than 3x over 10 minus 3 over 2. Another one is 5x plus 6y is greater than 30, and x is greater than 2. Now this we shall draw those lines as I've drawn in the graph. You can see the blue line is equating x is equals to 2, and the brown line, or looks like red, is equating 5x plus 6y is equals to 30, and the green line is equating y is equals to 3x over 10 minus 3 over 2. Now since x is greater in all those lines, y is greater in all those lines, what it means that we have to shade the lower parts of those lines. Now you can see I have shaded with the red the lower parts, so that the relevant area that remains is I have put the letter R to show it, the relevant area. The shaded parts are ignored. A mixed school can accommodate a maximum of 44 students. The number of girls must be at least 120, while the number of boys must exceed 150. Taking X to represent the number of boys and Y the number of girls, write down all the inequalities representing the information above. Now, we have the number of girls must be at least 120. So here it means that the number of girls must be greater than or equal to 120. So you can see the first inequality shows that the number of girls must be greater than or equal to 120. It cannot go below that. Now we have been told that the number of boys must not exceed 150. Oh, sorry, the number of boys must exceed 150. Sorry for reading that. The number of boys must exceed 150. Now this means that X, which is then the boys, must be greater than 150. Now we have been told that the school can accommodate a maximum of 140 students. So it means if you add the girls and the boys, so X plus Y, X must be less or equal to 440. That's the maximum number the school must accommodate. So if the boys and girls, the two genders must be less or equal to 140. So X plus Y is less or equal to 440. Sorry for the slip of tongue, 440. Solve the following inequalities and represent the solution on a single number line. Now we shall solve 3 minus 2x is less than 5 and solve 5. We solve them independently. So if we solve the first part, we find that x is less than x is greater than negative 1. Now we solve the other part. 4 minus 3x is greater or equal to negative 8. We solve and we find that x is greater or equal to 4. So bringing them together, we have here x is greater than negative 1, but at the same time x is less or equal to 4. Now on our number line, we find where negative 1 is. We put a circle showing that x is not strictly less than negative 1, because I've been told x is greater than x is greater than negative 1. It's not strictly negative 1. It can even go lower to negative 2. So that's where you put a circle showing that it's not strictly less than negative 1. Now we have been told that x is greater or equal to 4. So it means that we restrict x to 4. So that's the point. X cannot pass there. It's either it remains at 4. Solve the inequality and show the solution on the number line. Now we can solve the first part. 3 minus 2x is equal is less than x, and the other part independently. The other part is x is greater or equal to 2x plus 5 over 3. So solve for reading wrong, it should be x is lesser. X is less or equal to. Now if we solve the first part, we get that 1 x is greater than 1. The other part we find that x is less or equal to 5. So we write our equation x is greater than 1 and x is less or equal to 5. Now on the number line we mark 1. So x is not strictly less than 1. It can go even lower, because saying it's less than 1, it means it can even go to 0. Now the other part we strictly mark 5, because x cannot exceed 5. It's less or equal to 5. So you can see how I mark the number line. If the sum of 3 consecutive odd numbers is greater than 219, determine the first such 3 numbers. First of all, let's ignore the inequality so that we say the numbers are just equal to 219. So if the first number is x, because they are consecutive, the second number should be x plus 1, and the third one should be x plus 2. So if you add x plus x plus 1 plus x plus 2, you should get 219. So solving, we get that x is 72. So if there was no inequality, the first number should be 72. But we have been told the numbers are greater than 219 and they are odd in number. So the first number, the first odd number from 72 is 73. The next one is 75. The other one is 77. So the numbers are 73, 75, and 77. Solve the inequalities. 2x minus 5 is greater than negative 11, and 3 plus 2x is less or equal to 13, giving the answer as a combined inequality. So we shall solve the first part first. You can see the workings are solved. If we solve the first part first, we see that x is greater than negative 3. Now if we solve the other part, we find that x is less or equal to negative 5. So you can write that. You can see I've written there clearly that x is greater than 3 and x is less or equal to negative 5. Oh, so not negative 2, positive 5. Here it should be negative 3. Now, so since x is not strictly less than negative 3, we can start even with negative 2 so that we ascend, but reaching negative 5 and negative 5 is the limit, because x has to be less or equal to 5. So 5 is the limit. You can see the lower part we can extend a bit, but the upper part we cannot exceed the 5. Given the inequalities, x minus 5 is less or equal to 3, and then 3x, sorry for reading wrong. Given the inequality, x minus 5 is less or equal to 3x minus 8, which is less than 2x minus 3. Solve the inequalities. Represent the solution on a number line. So we shall solve the inequalities. The first part is x minus 5 is less or equal to 3x minus 8. Solving, we get that x is greater or equal to 1.5. The other part, 3x minus 8 is less than 2x minus 3. We solve and we find that x is less than 5. So I've represented it there that 1.5 is less or equal to x, and x is less than 5. So x cannot go below 1.5. That's why you can see put a mark that we cannot exceed 1.5. But for 5, x is relative because we have been told x must be less than 5, but not strictly. So it's relative. That's why I have put a circle there at 5. So meaning that x being less than 5, it can even be 4 or even 4.5. It should not be strictly 5. Solve 4 is less or equal to 3x minus 2, which is less than 9 plus x. Hence, list the integral values that satisfy the inequalities. We shall solve each part independently first. The first part I've solved and I've found that x is less or equal to 2. The other part I found that x is less than 5 and the first part is that x is greater or equal to 2, and the other part is that x is less than 5.5. Now writing as 1, we have 2, x is greater or equal to 2, and x is less than 5.5. Now the value that satisfies that we cannot exceed 2 on the lower limit. So we start with the 2, 3, 4, 5. We cannot say it is 5.5 because it has to be less than 5. So we take any figure that is lower than 5.5, and 5 is lower than 5.5. A school decided to buy at least 32 bags of maize and beans. The number of bags of maize and beans were to be more than 20, and the number of bags of beans were to be at least 6. A bag of maize costs 2,500 shillings, and a bag of beans costs 3,500 shillings. The school had 10,000 shillings to purchase the maize and the beans. Write down all the inequalities that satisfy the above information. Now the school has to buy maize and beans. Take maize to be x and beans to be y. So it has to buy at least. So the total of maize and beans should not go beyond the lower part, that 2. So it should be less or equal to 32. X and y should be less or equal to 32. And then we have been told the bags of maize must be more than 20. So x should exceed 20. X should be or let's say 20 should be less than x. And then we have been told the bag of beans must be at least 6 bags. So it should not be below 6 bags. So you say y should be greater or equal to 6. And then the budget. We have the bags of maize multiplied by the price, and the bags of beans multiplied by the price, we get the amount that the school has available to spend. So we have 2500x plus 3500y should be less or equal to 10,000, because the school cannot spend more than 10,000. It can spend less or just the 10,000. This, if we simplify this, it becomes 5x plus 7y is less or equal to 200. The diagram below shows a region R bounded by three lines L1, L2, and L3. Form inequalities that satisfy the region R. Now, the lines are given. The green line is x is equals to 4. You can see the upper part has been shaded. So this means that x should be less than 4. So that's the inequality. Now we have the blue line. The blue line is 2y is equals to x minus 6. You can see the lower parts have been shaded. So it means that 2y should be greater than 6 minus x. Now the other line, the equation is y is equals to x plus 1. You can see the upper part has been shaded. Now, which means that y should be less or equal to x1 plus to x plus 1. Solve the inequalities. We can solve we need to solve the lower part independently and the second part independently. So you can see, after solving the first part independently, x is greater than or equal to negative 5. And the other part, we find that x is less than 3/4. Now you can see I've visibly written that x is greater or equal to x is greater or equal to negative 5 and x is less than 3/4. Solve 5/3 minus 2x is less than 1 minus 2/3x, which is less or equal to 2 minus x. Hence, list the integral values that satisfy the inequalities. Now we solve the first part first. You can see I've solved and we have found that x is greater than a half. And we solve the other part to find that x is less or equal to 3. So because x is less than a half, it means we can even go lower than a half. We don't restrict ourselves to a half. That's why I've started with the number 0, 1, 2, 3. We have been told that x is less or equal to 3, so we cannot go beyond 3. So 3 is our limit there.